CoinMarketCap is a website that tracks real-time information on over 1,500 cryptocurrencies. We can access information like the global market cap, the global 24-hour volume, and as well as detailed information about each and every currency listed on their site. Their API listed at coinmarketcap.com/API has 4 public API endpoints. These are the listings endpoint, which allows you to access all active cryptocurrency listings in one call. The ticker endpoint, which allows you to access cryptocurrencies in order of rank. The ticker for specific currency endpoint. This will allow you to access detailed information about specific cryptocurrencies. And finally, the global data endpoint, which allows you to access information like the global market cap and the global 24-hour volume. They also return Unix timestamps, which we'll be converting into human readable format, and the endpoints are updated once every 5 minutes. So let's go ahead and get started. In this video, I'll be talking about the prerequisites and the environment that I'll be using to code these applications. So the first thing we're going to need is Python 3. If you don't have it already, you can download it from python.org under this download section. The text editor that I'll be using is Atom. It's a really nice text editor from GitHub. And if you don't have it already, go ahead and download this text editor. Now that we have Python 3 and Atom installed, the next thing we're going to do is set up our environment. So let's go ahead and create a new folder on our desktop called CoinMarketCap. And let's also put Atom and Terminal onto our dock. So just type Atom and drag it down onto your dock, as well as Terminal. So the first thing we're going to do is drag this CoinMarketCap folder into the Atom text editor, and that'll automatically open us up in the correct directory. So let's go ahead and save this file as hello.py. And I'm just going to be creating a simple hello world program just to show you our environment. Now let's open up the terminal, and we're going to navigate to this CoinMarketCap directory on our desktop. So just type cd for change directory, and let's get to our desktop. ls will list all of the directories on our desktop. So mine is CoinMarketCap, so I'm just going to type cd change directory CoinMarketCap. And we have one file called hello.py. Let's go back into Atom, save this file with Command S on Mac, and now let's run it with Python 3 hello.py. And if you're using Linux or Windows, you'll have to adapt this a little bit. Just know that you will only have to type Python hello.py. And now let's hit enter to run this program. And as you can see, it says hello world. It printed out what was over in our Atom text editor. So this is the environment that I'll be using throughout these tutorials. The first endpoint that we'll be accessing is the global endpoint. This endpoint allows us to access information like the total number of cryptocurrencies, the total active markets, the global market cap, global volume, and Bitcoin dominance. So scroll down to the bottom here, and here's our global endpoint. So we're going to be calling this URL in order to get this JSON response, and then we'll be formatting it. So go ahead and open up Atom and your terminal, and let's create a new file. And let's save it as CoinCap global.py. Now over here on terminal, you're going to need to install 2 libraries. And we can do that by saying sudo pip3 install, and the two libraries that we need to install are requests for retrieving JSON data from the web and JSON for formatting that data. And if you're using Windows, it's just pip install requests. Alright, once that's installed, go ahead and install JSON as well. Alright, the first thing that we need to do over here on our Python file is import JSON and import requests. Now let's get the global URL that we're going to be using to retrieve the JSON data with, which is just this right here. Let's put it in a variable named global URL. Make sure you put it in quotes. And now we're going to make a simple request. So request equals requests dot get global URL. So this gets the global URL and puts all of that JSON data inside of request, the variable request. Next, we're going to format that JSON data, and we do that by saying results equals request.json. And lastly, let's print out this JSON data to the terminal. And let's do that by saying json.dumps results, and then we'll set sort keys equal to true and indent equals 4. This basically puts it in a human readable format that we can easily understand. So now let's save this and run it inside terminal. So I'll say python 3 coincap global.py. And as you can see here, it printed out the same JSON data that was showing us here. Now we need to go through this JSON data and figure out exactly what data we do need and store that in variables. So now we're going to create variables out of this entire JSON tree. So the first value we want to get is active cryptocurrencies, and as you can see, we go down one level to data, then we go down again to active cryptocurrencies in order to get that value. So let's create a variable called active currencies, and we'll say active currencies equals results down one level to data, and then down another level to active cryptocurrencies. And let's just print this out. Let's also comment out this JSON dump. So save this and run it. And as you can see, there's 1,623 active cryptocurrencies. Now let's store all of the rest of our values. So we have active markets, which is equal to data active markets. Then we have Bitcoin percentage of the total market cap, and that's down at a similar level, data Bitcoin percentage of market cap. And then we have the last updated Unix timestamp, and we're going to convert this into a human readable format. And then we need to get the total market cap, so this one's down a few more levels. So we'll say global cap is equal to results data quotes, and then down one more level to USD, and then total market cap. And then our global volume, this one's very similar. Let's copy and paste this. The only difference is its total volume 24-hour. Now let's print out all of this data in a format that is easily readable. So first we're going to make some space, and then we're going to say there are currently, then we'll append active currencies. Then we'll append active cryptocurrencies, just saying that there are currently, and then active currencies contains the value of the number of active cryptocurrencies, and then we'll just say that's how many active cryptocurrencies there are. And let's append the active markets. We'll just say that's how many active markets there are. And let's convert, we'll typecast each of these variables into a string because they can come out as floats or ints. And now let's get the global market cap. We'll say the global cap of all cryptos is global cap. And we're going to format these later down the line in the next video. And I'll say, and the 24-hour global volume is global volume. Now let's print out that percentage, Bitcoin's percentage of the total global cap. So we'll say Bitcoin. If we want to use an apostrophe, you have to use this escape sequence with a backslash. So we'll say Bitcoin's total percentage of the global cap is Bitcoin percentage and then we'll say when it was last updated. This information was last updated on, let's say last updated. And we're going to format this information to make it look a lot nicer in the next video. And let's also make sure we convert all of these values into strings. And now let's try and print it out. So there are currently 1,624 active cryptocurrencies and 10,983 active markets. The global cap of all cryptos is this number, and that's hard to read because there's no commas, so we're going to add those. And the 24-hour global volume is this number. Bitcoin's total percentage of the global cap is 38.25. And let's just add a percentage sign after that. And the information was last updated on, this is a Unix timestamp, and we're going to convert this into a datetime object, which we can then print out in a human readable format. Now let's start formatting this data into a human readable format. So we're going to create strings out of these integers so that they can include commas. And we're going to set it equal to angle bracket, colon, comma, dot format active currencies. So this is just taking our active currencies integer from up here and converting it into a string separated by these commas. And we need to do that for active markets, global cap, and global volume as well. And we can just copy and paste. And the last two are global cap and global volume. And we're also going to convert that last updated timestamp into a human readable format. This is global cap. But first, let's try and print out these values that we just made. So replace each of these variables with the new strings. And global volume string. And let's try and print this. And as you can see, all these values are now formatted with commas. And the last thing I want to do with this is take out this 0.0 because it's always going to be, it's never going to have a cent value. So we might as well just turn it into an integer. And we can do that by coming up here to global cap and typecasting this whole thing into an integer. And do the same thing to global volume. Now let's save it and run it again. And as you can see, it took off that 0.0. The last thing we want to do is format this date into a human readable format. So we're going to do that by saying, well, actually first we need to import. So we need to import datetime. So we'll say from datetime import datetime. Now we're going to use this datetime object in order to create a human readable datetime. So we're going to say last updated string equals datetime dot from timestamp last updated dot strf time, which is basically string from time, and then we have to put our formatting. And in order to do that, let's go to this website called linux.die.net/man/3/strf time. And basically when you add these things called conversion specifier characters, they convert the timestamp into the equivalent, like weekday name, month digit. So our format is going to look something like this. We're going to have %B, which is equivalent to the full month name, then %d, which is the date, comma, %Y, which is the 4-digit year, at, then we're going to put the time, and we want the 12-hour version of the hour, 12-hour clock version. So that's percent uppercase I, colon, and percent uppercase M for minutes, and then percent lowercase p for AM or PM. And then let's change this value to our last updated string. And now let's print it out. As you can see, this information was last updated on May 25, 2018 at 11:54 a.m. and currently it's 11:58, so the next update should be happening at around 11:59. If you're outside of the United States or want to use a different currency, this is how you can do it. So we're just going to set our currency equal to USD, or let's say JPY for the Japanese yen. And then we need to add something to the end of our URL. We need to say $convert equals, and we're going to add the currency. And we also need to swap out on line 18 and 19 this USD string with the currency string. So let's go ahead and run this. And now all of these values are in the format of Japanese yen. The next API endpoint we're going to be using is this listings API endpoint. This one allows us to get the ID, name, symbol, and website slug of every single cryptocurrency listed on CoinMarketCap. There's over 2,500 of them. This gets all of the cryptocurrencies and a few over 1,000 assets as well. So let's go back to our Atom editor and we'll make a new file called, save it as CoinCap listings.py. So we're going to need to do a lot of the same things that we did before, like import JSON and requests. And we're also going to need a listing URL now. And that's equal to this URL right here. Now we're going to need to make our request like before, but we're going to swap out global URL with listing URL. And then we'll grab this JSON dump and put it here. And now let's just print out our results. This should get something very similar to how it is here, except it's going to list out all 2,500 or so currencies. So let's go to our terminal, type Python 3 CoinCap listings.py. So as you can see, 2,777 different assets and currencies are listed here, all of them with their IDs, names, and symbols. Now we need to print this in a readable format. So in order to do that, let's first comment out this JSON dump. And we're going to say for each currency, so for currency in our result, because this data, firstly, we needed to say data equals results at the data level, like before. But then we say for currency in data, as in it's going to grab each block one at a time, and then we can access them every single time it loops through. So for currency and data, we can access things at the currency level. So for example, currency ID in the 49th iteration of the loop would equal 49. And let's just store all these. Let's say rank is equal to currency ID. Name is equal to currency name. And the symbol is equal to the currency symbol. And these IDs up here are going to be very useful to us in the future when we want to access specific cryptocurrencies. So now let's print out something. We'll just say we'll print out the rank in a string format, and then a colon, and we'll print out the name of the currency, and then in parentheses the ticker symbol. And let's save that and run it. So as you can see, we now have all of these currencies and ticker symbols printed out according to their ID. The next endpoint we want to access is the ticker endpoint. Now this one is a little more complex than the previous ones. So we can only access 100 results at a time, and we can also set things like the start, such as starting at the 10th cryptocurrency all the way up to 110th, and we can set the limit. The default is 100, and we can set it to things like 10 to only get 10 cryptocurrencies. We can combine start and limit. Say like you want to start at number 10 and you only want to get 10, so it'll give you cryptocurrency number 10 through number 20. There's also sort. You can sort it by ID, rank, percent change 24 hours, and volume 24 hours. And there's also a structure. You can use a dictionary or an array. We'll be using an array because we want to loop through this data pretty easily and convert. Like before, we can convert it into a different currency if we want to. So let's go ahead and get started. Alright, we'll make a new file and we'll save this as CoinCap ticker.py. Alright, so like before, let's import JSON and requests. And we need the ticker URL. And that's right here. And we already know we want to structure this data as an array. So let's go ahead and append $structure equals array as a parameter that's already set. And then save this. Next thing we need to do is ask the user if they want to enter any of their own parameters. So if we want to enter in things like the start number, the limit, or a sort ID, we can do that by just asking the user. So let's set these to the default values first. So limit is equal to 100, start is equal to 1, sort is equal to ID, and convert, which is basically the currency, is equal to USD. And then we're going to ask them if they want to enter any. So we'll say choice equals input. Do you want to enter any custom parameters? Yes or no? And then if they say yes, so if choice is equal to y, then we'll present them with some options. So the limit is equal to the input of do you want to, or we'll say, what is the custom limit? And they can just click enter to skip it. And then the start is equal to what is the custom start number. Sort is equal to what do you want to sort by, and convert is equal to what is your local currency. And now we need to add all of these results we got to the ticker URL. So we're going to say ticker URL plus equals, and as you can see over here, we need to add things like and limit equals and sort equals. So we'll say and limit equals plus limit, and then and sort equals plus sort, and start equals start, and convert equals to plus convert. And now we can make our request. So I just copy and pasted that from before. Request equals request.get ticker URL. And then we can print out our results. So let's just go ahead and do that. And we'll run our program. It's CoinCap ticker.py. Do you want any custom parameters? Yes. Our custom limit is 10 currencies. We want to start on the 22nd currency. Sort by ID. And what is your local currency? USD. So this got 10 currencies, starting with the 22nd currency, which is a non-coin. And actually, we need to change this slightly to sort by the rank. So let's rerun it. So custom limit 10, start 22, I want to sort by the rank. Our local currency is USD. And there we can go. The 22nd currency is OmiSco, 23rd is Icon, 24th is Lisk, and so on, all the way up to the 32nd currency. Now let's store all of these variables within Python so we can use them later on. So data is equal to results down at the data level. And then we'll make some space here and say for each currency in the data, we need to get these values. So we're down at this level for each currency, and we're going to try and capture all of these. So for currency in data, the rank is equal to currency rank, the name is equal to currency name. The symbol is equal to currency symbol. And then the circulating supply is equal to circulating supply. And let's convert this one into an integer, just so it doesn't have that 0.0 at the end. And then the total supply, similar. Let's copy this. Next, let's go down to the quotes level. It's at the currency quotes convert. Convert is equal to like USD or whatever your local currency is. And now we can get all of these values down at this level. So the market cap is equal to quotes market cap. The hour change is equal to quotes percent change 1H. So I'm just going to copy and paste this to get the day and the week change. So this is 24 hours, and this one is 7 days. And the price is quotes price. The volume is quotes volume 24H. So now let's format our data into a human readable format, and let's also start printing everything out. So some values that we want to turn into strings with commas would be the volume, market cap, circulating supply, and total supply. So we'll say volume equals angle bracket, colon, comma, dot format volume. And let's do this to all three others. So we've got market cap, circulating supply, and total supply. Got market cap, circulating, and total. Now let's start printing everything out. So we'll print out the rank, typecasted to a string, plus colon, and then the name of the currency, and then the symbol. Alright, so now let's print out the market cap. We'll print out that string version. And then we'll print out the price. Add let's add a dollar sign to these. Plus the typecasted price, 24-hour volume, and we have this one as a string. And then we need the hour change, day change, and week change. Plus hour change. We'll add a little percent symbol after that. I'll just copy and paste this for the day and the week. Now we need to print out the circulating supply, total supply, and then we'll do the percentage that is circulating as a little equation we can add in there. We'll print out the string version of this one. And let's also typecast these changes to strings. And we'll make a little bit of, or actually let's calculate this percentage of coins in circulation. And we're going to say circulating supply divided by total supply. Convert this into an int. And also needs to be finally typecasted as a string. Make a little space, and let's try and print this out. Must be string, not int. So we need to typecast our limit to a string as well as our start value in case we say no in the beginning. So save that. Name quotes is not defined. Quotes equals currency, quotes convert. Okay, so this quotes needs to be in quotes. So save that. That's spelled wrong. All these are spelled wrong. Oh, percent change. Save it and run it. And there we go. So this printed out the ID of each. So we need to change our default sort from ID to rank. And now let's run it. And there we go. These are the top 100 ranked correctly. And now let's format these numbers to print out a little nicer. So we're going to add some tabs before all of these right here. And so market cap will get 1 tab or 2 tabs. Price will get 2 tabs. 24-hour volume, 2 tabs. So you add 1 more tab to price. Hour change, that's 2. Got 2 for day change. Week change, 2. Circulating supply is 1. Total supply has 2. And percentage of coins in circulation doesn't need any. So now let's save it and run it. And there we go. That's formatted a little nicer. So if the user wants to run it again, let's just add a quick option for them to run again. So we'll say choice equals input, again, yes or no. Then we'll say if choice equals yes or no, then we'll break out of a while loop. So let's add everything up to this point. Actually up here. Say while true. Make an infinite loop until they break out of it. So now just press tab to get everything down into this loop level. And that's about it for the ticker API endpoint. Now let's move on to getting specific currency data. The final API endpoint is the ticker for a specific currency. So with this API call, it's basically just like the ticker from before, but we're going to add the ID right after the ticker in order to specify which currency we want to retrieve. So let's go ahead and get started. We'll make a new file called CoinCap specific.py. And we're going to import requests, import JSON, and first thing we're going to do is let people who need to use different currencies have that option. And then we're going to get our listings URL. This isn't the ticker URL, but we're going to need this listings URL in order to create a dictionary which contains all of our currencies and all of the IDs associated with those currencies, so that we can use those, so that we can call those currencies in order to get the ID associated with it. That way we can easily access the IDs needed for this ticker URL. So the listings URL from before is this. And let's go ahead and make that request on it. And the data is equal to results at the data level. And now we're going to create a dictionary called ticker URL pairs. Dictionaries are like arrays, but they store key value pairs. And this one's going to store the ticker symbol as the key and the ID as the value. So we're going to say for currency in data, the ticker symbol is equal to currency at the symbol, and the ID, what's called the URL, is equal to currency at the ID level, the ID key. And now let's append each of these to our dictionary. So ticker URL pairs with symbol key is equal to the value URL. So for example, Bitcoin, if its ID was 1, whenever we try and call ticker URL pairs Bitcoin, BTC, it's going to return the value 1. And I'm just going to print out this entire dictionary so we can easily see what's going on. This is CoinCap specific. Listing URL is not defined. Get that S out of there. And as you can see, these are all ticker symbols with their ID pairs. So whenever we call this ticker symbol, it'll return that ID. Now we're going to ask the user which currency they would like to see details about. So we're going to make an infinite loop that'll be canceled by the user whenever they're done picking currencies. So let's make some space, and we'll say choice is equal to the input, enter the ticker symbol of a cryptocurrency. And whatever they say they do Litecoin and they say LTC, if it's uppercase or lowercase, we need to always be uppercase, because that's what our keys are in our dictionary. They're all uppercase. So we'll just say choice is equal to choice.upper. And then let's create our ticker URL from their choice. So our ticker URL is equal to, let's get it from CoinMarketCap's website. We'll take out this last number 1 here, because we're going to add our own ID here. So we need to say plus the typecasted string of ticker URL pairs with key value choice. So if they said LTC here, we're going to get the value of the choice. Basically, it'll pass an LTC to our dictionary, and whatever's stored with an LTC key, it'll return that value. And as you see here, this number 1, you basically replace this number with the ID of the currency that you want, and it returns information about that currency. Like Bitcoin has ID 1, Litecoin may have ID 3, 4, or 500, but whatever is associated with that ID will return the correct values. And then after this, we need to add a plus and URL end. So we need to define what the end of the URL will be. Let's do that up here. Getting a little past the wrap here. So URL end is equal to structure equals array, because we want the JSON data to be in the array format, and convert is equal to, let's convert to get the local currency. Now we'll save this and we'll print out that JSON data. Let's get it from another file. Now let's try and run this. We'll say Bitcoin, error null. Let's make sure we got this right. Enter the ticker symbol of a cryptocurrency. We have slash plus string ticker URL pairs choice plus slash. Here, let's print out our URL and see what's wrong with it. And you can press Control-C to cancel the running of a program. Try Bitcoin again. Oh, we forgot to do a request. Sorry about that. So we got to do request equals results.get ticker URL. And now our results will be correct. Let's Control-C, we'll run it again. Bitcoin. And there we go. There's data about only Bitcoin. This time, as you can see over here, we only have one item in our array, so we don't necessarily have to loop through each and every single cryptocurrency. So let's go ahead and just say results or data equals results at the data level at the 0th index. Because otherwise we'd be looping through each and every index, but we only need, for the specific instance, everything at the 0th index. And now let's go back over to our ticker API, and we can just grab all of this and use it again. Make sure everything's on the same line. And instead of data, let's call this currency just to match. So let's run this, and it should only print out one specific currency after it asks us. So let's say Litecoin. And there we have Litecoin has the market cap. All this looks accurate. And the percentage of coins in circulation, we need to change this to multiply it by 100 in order for it to be correct. Let's change that on our ticker as well. And let's get rid of these two prints. The ticker URL pairs. And let's get rid of printing out the ticker URL as well. Save that. And let's run it again. Say Litecoin. And there we have Litecoin. We'll go again. How about Ethereum? And there we have Ethereum. For our first project, we're going to be creating our own cryptocurrency portfolio. And as you can see here, you just list all of the cryptocurrencies you own in a text file along with the amount you own. And then after we run our Python program, we can see the USD value, current price, 1 hour change, daily change, and weekly change for all of these assets. And we can also see the total portfolio value, and all of these are color coded for our convenience. So to get started with this project, we're going to need a couple libraries beyond requests and JSON. So the first library we're going to need is called PrettyTable. To install that, just say sudo pip3 install PrettyTable on Mac, or pip install PrettyTable on Windows. Just enter your password. And the next one we're going to need is called Colorama. And that's to color our results inside terminal. So it's called Colorama. And now that we have our two libraries installed, let's go ahead and start coding. Now that we have the necessary libraries installed, let's go ahead and start coding. I'm going to call this file CoinCap p1.py. So to get started, we need to add the libraries to our project. So we'll just say import OS, import JSON, import requests, and then we have from datetime, import datetime, from PrettyTable, import PrettyTable. PrettyTable is going to be a library that we use to format our data nicely in a table format. And then from Colorama, import for, F-O-R-E, back, and lastly, style. So now let's create our base URLs to call. First thing we're going to do is add a convert in case you're using a currency other than the US dollar. And then let's create our listings URL. And we're going to set this to api.coinmarketcap.com/v2/listings, and then the option for convert is equal to our convert variable. And then let's make our API call. So it's request is equal to requests.get listings URL. And this will return all of the JSON data from that listings URL. And then we gotta format our results as JSON. So we'll say results equals request.json. And finally, we'll get the JSON data down at the data level. So we'll say data equals results at the data level. So this stores our tree down at the data, just at the data level. So next, we want to create a dictionary like we did before for our specific API call called ticker URL pairs. In fact, we can just use all of this code and copy it right back into our project. So now we have a dictionary of symbols along with their associated ID, so that whenever we specify a symbol, it'll make the correct API call and get all of that data for the specific cryptocurrency. Now that we have the necessary libraries installed, let's go ahead and start coding. I'm going to call this file CoinCap p1.py. So to get started, we need to add the libraries to our project. So we'll just say import OS, import JSON, import requests, and then we have from datetime, import datetime, from pretty table, import pretty table. Pretty table is going to be a library that we use to format our data nicely in a table format. And then from Colorama, import for, FORE, back, and lastly style. So now let's create our base URLs to call. First thing we're going to do is add a convert in case you're using a currency other than the US dollar. And then let's create our listings URL. And we're going to set this to api.coinmarketcap.com/v2/listings, and then the option for convert is equal to our convert variable. And then let's make our API call. So it's request is equal to requests.get listings URL. And this will return all of the JSON data from that listings URL. And then we gotta format our results as JSON. So we'll say results equals request.json. And finally, we'll get the JSON data down at the data level. So we'll say data equals results at the data level. So this stores our tree down at the data, just at the data level. So next, we want to create a dictionary like we did before for our specific API call called ticker URL pairs. In fact, we can just use all of this code and copy it right back into our project. So now we have a dictionary of symbols along with their associated ID, so that whenever we specify a symbol, it'll make the correct API call and get all of that data for the specific cryptocurrency. And now we're going to create the beginning of our menu. So let's just say my portfolio. And now let's create a text file that'll contain all of our assets and the amount that we own. And we'll call this portfolio.txt. And if you currently own any, you can put in those values. I'm just going to put in some arbitrary values. So 1.23 Bitcoin, like 24 Litecoin, and 3.33 Ethereum. And it doesn't matter if these are uppercase or lowercase, because we'll be fixing that in the code. So now let's create some values that we'll be appending to in the future. The first one will be the portfolio value, which will contain the total value of our portfolio. And we'll make this a double and just give it the value of 0.00, because we're starting off with value of 0. And then we're going to have a last updated variable, set that equal to 0. This is going to contain a timestamp of when the data was last updated, and we'll use that to tell the user how recent these values are in their portfolio. And lastly, let's create a table out of our pretty table library, and this will just contain the headers of our table. So we're going to say table equals pretty table, and then parentheses, square brackets, and now we're going to name off all of the headers. So we're going to have asset, amount owned, USD value, or if we're using a different currency, I'm just going to say convert plus value, and then price, and 1 hour change, daily change, and weekly change. And now we're going to read in our portfolio.txt file and handle all of the values that were entered by the user. So we can do that by saying with open portfolio.txt as input, which I'm just going to call INP. And then, so now we've basically stored all of this data inside of our variable INP. So now we're going to say for line in INP, it's basically going through each line in our text file. We want to store the ticker symbol that they inputted as well as the amount. So we'll say ticker comma amount equals line dot split. So this just splits that line in half using the spacebar character wherever it finds a spacebar character. So as you can see, this will be stored in ticker, and this amount value will be stored in value or amount. And in case they entered lowercase values, we need to convert them to uppercase to match with our keys within our ticker URL pairs dictionary. So ticker equals ticker.upper. Now we need to generate a ticker URL. So we'll say ticker URL, and this will be used to call the API. It's equal to https api.coinmarketcap.com/v2/ticker, and add one last slash there, and then we're going to get the current ticker that we're on, because we're reading in the portfolio one line at a time. So in our example, we'll first be on Bitcoin, then Litecoin, then Ethereum. So we're going to read in ticker URL pairs at the index of ticker. So ticker will be something like BTC, and this ticker URL pairs dictionary stores all of the tickers like BTC, LTC, ETH. It stores all 1,500 plus of them, and then we're going to be getting the ID, because this URL right here requires us to add the ID at this point right here in order to get a specific currency. It gets all of the data associated with that currency's ID. And then we'll say plus slash plus URL end. And let's go ahead and define what URL end will be up at the top here, because we need to format this data as an array. So we're going to say structure equals array and convert equals plus convert. So this will just say USD or JPY. So now let's make our API call for the ticker URL. We'll say request equals requests.get ticker URL, and results is equal to request.json. And now we're only going to have one API result, so we're going to get the currency, we're going to set the currency equal to results data 0, whereas we usually set it to just data. All we're going to be getting is the first index of the data array. And now we can use that data to get our rank, the name of the currency, the time it was last updated, and we can get the symbol. We'll also need to get the 1 hour change, 24 hour change, 7-day change, and the price. So let's create a quotes variable to get down to that quotes level. So quotes is equal to currency quotes, and then usually we would say USD, but we're going to say convert here in case anyone's using a currency other than USD. And then we'll say hour change is equal to quotes percent underscore change underscore 1H. And then day change is equal to quotes percent change 24 hour. And week change is equal to percent change 7-day. And finally, price is equal to quotes price. And now let's calculate the value of each individual asset. And the way we do this is multiplying the price of the asset by the amount that we own. So we're going to say value is equal to price typecasted as a float times amount typecasted as a float in case they get returned as strings. And we're going to add this to our portfolio value up here. So it starts off as $0, and as it goes through each currency, it adds that currency's value to our total amount. So we're going to say portfolio value plus equals value. Now let's format our value in a human readable way. So we're going to say value string is equal to quotes, curly braces, colon, comma. And this will add a comma at every third place in our decimal value. And we're just going to round this value down to 2 decimal places. So we'll say round value, comma 2. And now let's start adding these values to our table. So we're going to say table.add_row and parentheses and square brackets. And now we're going to add our values one at a time, the same way we added the headers above. The first one is asset, and we're going to say name, for example, Bitcoin, and then we're going to append the symbol in parentheses. So this will be Bitcoin parentheses BTC, for example. And now, so we don't make this line too long, we're just going to say comma, enter, and we're just going to add our next values on new lines. So the next one's going to be the value string. So we'll say $ plus value string. And then the price, so $ plus price, or typecast it as a string price. And then we have the hour change. So we'll just say string hour change. Then we have the day change. And finally, we have the week change. And so you have to make sure all of these are in the same order as they are up here. And everything checks out. And now finally we can come down here and print out our table. And let's also print out the total value of our portfolio. So let's format that value as in human readable format. So we'll say portfolio value string is equal to this right here. So we have the curly braces, colon, comma, dot format, round, portfolio value, and we'll round it to 2 decimal places. Let's also convert our timestamp into a human readable date. So we'll say last updated string is equal to date time dot from timestamp last updated. And now, like before, we need to use strf time in order to format this how we want it. And we're going to have the same format as before. We're going to say %b for the name of the month, like May, and then %d for the number of the day, %uppercase Y for the 4-digit year, and then we'll list the time, %uppercase I for the time in the 12-hour format, %uppercase M for the number of minutes that have passed, and %lowercase p for AM or PM. And now let's print out these results. So we're going to say total portfolio value, and this will be set to our total portfolio value string. So we'll just say plus portfolio value string. And now let's print out when it was last updated. So we'll say API results last updated on plus last updated string. And this will be good to know because the API updates every 5 minutes, and if you need your results back very quickly and precisely, you can know how many minutes have passed since the last time the API was updated. So finally, let's add the colors that are listed with the changes to our project. And we're going to do this by saying if our change is greater than 0, then we're going to reset it to be our change equals, and this is where we get into the colorama library. We're going to say back.green, and green is in all caps, plus string format of our change, and then we're going to add a percentage sign, because it's like 3.4% change, things like that. And then we're going to say style from the Colorama API, reset underscore all. And if it's not greater than 0, then we're going to set it to be red. So I'm just going to copy and paste this. And instead of back.green, we'll say back.red. Now we also need to do this for the day change and the week change. So we'll just copy and paste this twice. And we're going to change, well, let's say Command F, we'll find our change. And where they occur, we're going to say day change at the right places. So let's get to the right spot here. Replace, 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 and replace. And now we need to replace these with week change. And go ahead and replace all these. So now these should have the correct color format. And the last thing we want to add a color format to is our total portfolio value down at the bottom. So we're just going to say back.green. Also add a $sign plus portfolio value string, and then let's stop it here. So style.reset all. And now let's save this, and let's go ahead and try and run it. So I'm going to change into my CoinMarketCap folder. Oops. Oh, I'm in the wrong directory here. So you can just say cd to go back to your home directory. And I'll say cd desktop CoinMarketCap. Let's list them out. And then it's CoinCap Python 3 CoinCap underscore p1.py. So we had an error here. Row has incorrect number of values. 6 does not equal 7. So we have 7 values listed down here. 1, 2, 3, 4, 5, 6. I guess we have 7 up here. Asset amount 1, 2, 3, 4, 5, 6, 7. So what do we have extra here? Asset amount owned. So we forgot to add we have the name, we have the value. Okay, so we need the amount right here. Sorry about that. Let's just save it and run it again. And there we go. We have our total portfolio value. I had a small typo here. Let's save that. So now if we change this at all, let's say we add Bitcoin Cash 2.4536, or we add some BitConnect. So everybody wants BitConnect 34.83. And let's add some IOTA with the ticker MIOTA. We'll add 1,000 of that. Let's save it and we'll run our program again. And there we go. And wow, we got 17 grand. And our API result for last updated 804, and it's 804 right now. Good stuff. So I'll see you guys in the next project. So in this project, we're going to make a program that alerts us when specific cryptocurrencies hit specific values. And you can set these to all-time highs, maybe just numbers that you're looking for that you want to sell at, and the computer will actually speak when this alert happens, and you can make it say whatever you want. So say when you go to sleep, but you still want to know if Bitcoin hits, say, 20,000, or Litecoin hits 100 or 200, you can set your computer to loud, go to sleep, and this thing will wake you up shouting whatever you want. So over here we just have some alerts, and let me run this program. And Litecoin is above 100 right now, so this will automatically trigger this Litecoin alert. But this program will be checking once every 5 minutes to see if the prices of these specific cryptos have reached these values, because the CoinMarketCap API gets updated once every 5 minutes. So I'm going to run it. It says alerts tracking. And if you could hear that, it said Litecoin hit 100. Doesn't know how to say Litecoin, but I'll play it again a little louder.
Litecoin hit 100.
And there you go. And now we can make this say whatever we want when any of these alerts get hit. And it also will have a little reminder here of when it hit a certain value. So to get started here, we're going to create a new file, and we're going to call it CoinCap p2.py. And we're going to be using similar libraries as in our first project, and we're also going to be storing all of our data in the Tkinter URL pairs dictionary. So let's just copy everything up to this point and bring it on over to project 2. We can actually take out Colorama and Pretty Table. One library that we are going to add though is called time, and this will allow us to wait 5 minutes to make the next API call. So to get started, we're going to just say alerts tracking to let the user know that we're tracking. And now we're going to create an array called already hit symbols. So say Litecoin hits 100 and it gives you an alert. We don't really want it to give us another alert every 5 minutes if it stays above 100. So we're going to make a check on this array and see if we already hit certain tickers. And we're going to create an infinite loop because we want this program to always be running in the background. So we'll just say while true, and then we're going to create our alerts text file, similar to the portfolio one we created in the last project. So let's say file, new file, and we'll save it as alerts.txt. And just set an alert. I'm just going to set Litecoin to 100 because I know it's higher than 100 right now, and it'll trigger immediately. And I also want to set Bitcoin for 1 million. So once Bitcoin hits 1 million, I'll get whatever I programmed this project to say shouted at me. So First thing we're going to do is open up this text file, alerts.txt. So similar to the last video, we're going to say with open alerts.txt as IMP. And then for line in INP, we're going to say ticker amount equals line.split. So it's going to store the ticker in the ticker variable and the amount, which is the price we want to hit, in the amount variable. And then we're going to say ticker is equal to ticker.upper so that it matches with our dictionary keys. And then ticker URL. And let's just copy that from our last project. And now let's make our API call. So request equals requests dot get ticker URL, and results equals requests dot JSON. Now let's get all of our data from the API. So we'll say currency equals results data 0, because we're only calling one specific currency, and that's going to be at the first index. And then the name is equal to currency name. The last updated timestamp is equal to currency last updated. And we also need the symbol, the quotes level, and the price. So we're going to say symbol equals currency symbol. The quotes level is at currency quotes, and then convert for other currency types. And price is equal to quotes price. Now we need to check if we need to trigger any alerts. So basically, if the price of the current cryptocurrency is higher than any of the alerts that we have set for the specific cryptocurrencies, then we trigger the alert. So we're going to say if float price is greater than or equal to float amount, and we also need to check if the current symbol is not in the already hit symbols array. So we just say and symbol not in already hit symbols, just to make sure we don't give redundant alerts. So after this, we need to basically just call our alert. So we're going to say on Mac, we can say os.system say, and anything after the say command, the computer will say out loud. So we'll just say name, such as Bitcoin, hit, and price. Let's say price. Or let's say amount, so that it's the user specified amount. And then let's turn our last updated variable into a string, and we did that in the last project. Last updated string equals date time from timestamp. And we'll also print name of the currency, hit, amount, on last updated string. So this will say like Bitcoin hit 1,000 on so-and-so date. And last thing we need to do is append the symbol that we just hit to our already hit symbols array. And now, just to let the user know the program is still running, we'll just print out 3 dots. So these will pop up every 5 minutes. And in order to make the loop only trigger once every 5 minutes, we just say time.sleep. And this is in seconds, so we'll say 300. So make sure your project2 file and your alerts.txt file are saved. And now let's get there on terminal. So I'm going to say Python 3 CoinCap p2.py. Request results equals requests.json. This needs to be line 36. This needs to be request.json rather than requests.json. We'll just save that and run it.
Litecoin hit 100.
And there we go, Litecoin hit 100. In project 3, we're going to be creating an application that allows us to sort the top 100 cryptocurrencies by rank, 24-hour price change, and 24-hour volume. So I'll go ahead and show you what it looks like. So if we select 1, they're sorted by rank. If we select 2, they are sorted by 24-hour price change, as you can see in this column. Intelligent Trading Foundation coin is doing very well today. And 3 is 24-hour volume. And as you can see, the volume sorted on this column. So let's go ahead and get started with this code. For this project, we're going to need the same libraries as we used in project 1. So the extra ones that we'll need are Pretty Table and Colorama. And if you haven't installed those already, you can install them with pip3 install Pretty Table and pip3 install Colorama. So let's go ahead and get started. We're going to need JSON. But first, let's save this file. Save it as coincap_p3.py. So we'll import JSON, import requests, then from datetime, we'll import datetime. From Pretty Table, we'll import Pretty Table. Make sure to get the capitalization right. And from Colorama, we'll import for, F-O-R-E, back, and style. First off, we're going to set that convert for people using currencies other than the US dollar. And then we're going to make a call to our global URL so that we can display the total global cap of all currencies inside of our menu. So the global URL is equal to https api.coinmarketcap.com/v2/global. And then we also have to add $convert equals and then our convert value, which is the currency. And now let's make our API call. So request equals requests dot get global URL. Results is equal to requests dot JSON. Data is equal to results at the data level. And then we need to get the global cap, and we also need to convert that into a human readable format. So the global cap is equal to data quotes convert total market cap. And then we need to convert this to an integer, just because this one always has 0.00 afterwards. They never have like cents. And global cap string is equal to curly brace colon comma dot format global cap. And now we're going to loop through our menu. We're going to be able to specify whether we want to run this again. So we're just going to make an infinite loop that's canceled by the user. And first off, let's create our menu. So we'll just say, make some space. We'll say CoinMarketCap Explorer menu. And we'll specify what the global cap currently is. The global market cap is, and then global cap string. That's the formatted value from up here. And then we have to give them their options. So we'll say 1 is equal to top 100 sorted by rank. 2 is equal to top 100 sorted by 24-hour change. 3 is equal to top 100 sorted by 24-hour volume. And if they want to exit out, we can give them option 0 to exit. Let's fix this. And then let's get their choice. We'll say choice is equal to input. What is your choice? And we'll say 1 through 3. So now we need to specify the ticker URL with our specific sort based on the user choice. So our base URL is going to be equal to the ticker URL, so https api.coinmarketcap.com/v2/ticker /structure equals array, and sort equals, and then based on their choice, we'll append that to the end of this base, or the sort type to the end of the base URL. So if choice equals 1, then ticker URL plus equals rank. If choice equals 2, ticker URL plus equals % change 24 hours. If choice is equal to 3, then the ticker URL plus equals volume 24H. And lastly, if the choice is equal to 0, then we'll just break out of the while loop. Now we need to call our API. So we'll say request equals requests.get ticker URL, and results is equal to request.json. And finally, data is equal to results at the data level. And now let's create our pretty table. So table equals pretty table, parentheses, square brackets, and now we have to list out everything we want to include in our table. So for me, I'm going to say rank asset, which is like Bitcoin, and it'll have the ticker symbol as well. Then we'll have price, market cap, and not all currencies are going to have a market cap in case if they're like really new to CoinMarketCap.com. And oftentimes, if you sort by 24-hour price increases, you'll get really small new currencies without market caps. And we're going to handle that case if we get a currency without a market cap. And then we have volume and 1 hour change, 24-hour change, and finally 1 week change. Now we're going to begin looping through each currency in the top 100. So we'll make a little space here, and we'll say for currency and data. So this is getting the currency at each index of the top 100. And we'll get the rank. So rank equals currency rank. We will get the name. The name is equal to currency name. We'll get the symbol. And we need to get down to the quotes level. So quotes equals currency quotes. Let's see if we have a convert up here. Yeah. So down at the convert level. And market cap is equal to quotes market cap. Hour change is equal to quotes percent change 1H. Day change is equal to quotes percent change 24H. Week change is equal to percent change 7 days. And finally, we need the price and the volume. So price is equal to quotes price, and volume is equal to quotes volume. So now we're going to get into some calculations on these values, such as turning the value green if it's above 0% and turning it red if it's below 0%, similar to how we did it in the first project. And we're also going to be making some changes to the market cap string and the volume string by formatting them. And the problem is, if these values don't exist inside of the API, then they'll return as none type. And if we get a none type, then it'll throw an error. So we have to account for the fact that hour change, day change, week change, market cap, and volume can all return none type. And this is how we'll do it. So we'll say if our change is not none, then we'll check if it's above or below 1%. So we'll say if our change is greater than 0, then we turn it green. So we'll say our change equals back.green, green's in all caps, plus the string form of our change, plus %. And then we'll say style reset all. And if it's not, then we need to turn it red. So let's copy and paste this. And instead of green, we'll make it red. And now we need to do this for day change and week change as well. So we can just copy and paste this. And let's do Command F or Control F. And we'll replace all of the hour changes here with day changes. So find the correct one, and then let's start replacing them. And then for all of these, we need to replace it with week change. Now let's format the volume and the market cap so that they're in a human readable format. So we'll say if volume is not none, because oftentimes these early brand new cryptocurrencies may not have volumes listed. We'll say volume string is equal to curly braces, colon, comma, dot format volume. And then we'll say if market cap is not none, we'll say market cap string is equal to same thing, dot format market cap. And now we need to start adding some rows to our table. So with each cryptocurrency that we loop through, we're going to be adding one row to our table with these values that we produced and got from the API. So we'll say table.add_row, and then square bracket rank, comma, I'm going to put on a new line to make it more readable, name plus parentheses symbol. And then we'll add the price. So the string form of price typecasted. And then we'll add the market cap with a $sign. And then we'll add the volume string. Then we'll add the string hour change. We'll add the day change, the week change, and that'll do it. So now finally we just gotta print out the table and ask the user if they want to go again. So we'll just say print to make some space. We'll print out the table and make some more space, and then ask them if they want to go again. So input again, yes or no. And if they choose no, so if choice equals no, then we'll break out of the while loop. So now let's run this. So Python 3 CoinCap p3.py. Results equals requests.json. So up here on line 12, we need to turn requests into request. So one for top 100 sorted by rank. Key error volume. So that key actually needs to be volume 24 hours. So volume underscore 24h. Save it. Ooh. Let's try and run that again. I may have forgot to add the style.resetAll to some of these. It looks like they all have them. Let's just try and rerun it. Okay, so there we go. And as you can see, these are all sorted by rank. And then if we press 2, they'll be sorted by 24-hour change. And if we press 3, run it again, press 3, and they're sorted by 24-hour volume. So that's it for project 3. I'll see you guys in the next video. For project 4, we're going to have some real-world application. So on CoinMarketCap's website, we can see the global market cap here, currently at 325 billion. This is the combined US dollar value in all of the cryptocurrencies. So what we want to do is we want to calculate the price of each of these cryptocurrencies if this global market cap were to increase. So say this global market cap increases 10 times to 3.2 trillion, then the price of Bitcoin would also increase 10 times to 70,000. That's considering that these percentages of the market cap that each currency holds stay the same. And we're going to get all of these numbers from this article. In this article, each square represents $100 billion. And as you can see, when this article is written, cryptocurrency represented only about one square, which was $100 billion. While Apple represents 8 squares, valued at $800 billion. The richest people, all combined, represent $1.9 trillion. Numbers like the world's stock markets, if cryptocurrency were to reach that, it would be $73 trillion, and so on. So in our program here, you can see we have the current value, the price if it were to reach 7.7 trillion. So for example, 170,000 for Bitcoin. Narrow money, which is the money that's circulating in cash and coins, 36.8 trillion. And Bitcoin would be at almost a million at that point. The world stock market's at 73 trillion. Bitcoin would be at 1.6 million. Broad money is money in bank accounts along with coins and cash. Would make Bitcoin over 2 million. 217 trillion, which is the total value of all real estate combined. That would make Bitcoin almost 5 million. And then 544 trillion, which is derivatives such as options contracts, futures contracts, things like that, would make Bitcoin 12 million. The most realistic number is around broad money because that's the money that people are spending on a daily basis. The libraries that we're going to need for this project are math, JSON. Actually, let's name this file first. We'll call it CoinCap p4.py. And we're going to need locale. Locale is another way to add the commas to our numbers, to our very large numbers. so they're in a human readable format, so it adds a comma to every third decimal place, every third integer spot. So we're also going to import requests, and lastly, from pretty table, we're going to import pretty table to make our data look nice. And now we're going to set our locale, and this basically says where your home country is. So if you're outside the United States, you can use this to easily like add commas where the dots would be in decimal places, for example. So locale.lc_all, comma en-us.utf-8. We'll save that. And now we're going to make a call to our global URL. So we're going to say global URL equals https://api.coinmarketcap.com/v2/global. And we'll also add the ticker URL up here while we're at it. So the ticker URL is equal to https://api.coinmarketcap.com/v2/ticker, and the structure will be equal to array. And now we're going to say our request is equal to requests.get. We're going to use the global URL. Result is equal to requests.json. Data is equal to results at the data level. And then we need our global cap, and that is equal to int data down at the quotes level. And we go down again to USD and total market cap. And now we'll set the headers for our table. So table equals pretty table. And our headers will be name, ticker, percent of total global cap, current, it's the current price. Then we'll have 7.7 trillion for gold. We will have 36.8 trillion for narrow money. And 73 trillion for world stock markets. And then we'll have 90.4 trillion for broad money. And then we have real estate at 217 trillion. And finally, derivatives at 544 trillion. Now we're going to make a call to the Ticker API endpoint. So we're going to say request equals requests dot get ticker URL. And then results is equal to requests.json. And finally, data is equal to results data. Now we're going to loop through this information. So we're going to say for currency and data, name is equal to currency name. Ticker is equal to currency symbol. Percentage of global cap. This is something we're going to calculate. And this is the percentage of the global cap that this specific currency that we're on contains. So say if we're talking about Bitcoin and Bitcoin's market cap is 100 billion while the global cap is 300 billion, then Bitcoin would have 33% of the market cap. And we're going to use that value to basically calculate the future values, assuming that the percentage of global caps stay the same into the future. So we're going to get the typecasted float of the market cap of the currency we're currently on. So it's down to quotes USD market cap level. So that'll get the value of the market cap. And then we need to divide that by the global cap. So we'll just say divided by float global cap. Next, we're going to get the current price. So that is equal to, current price is equal to, and we're going to round this down, and it's also going to be typecasted as a float. Currency quotes USD price. And then we're going to round this to 2 decimal places. And let me make sure I spell that correctly. And available supply is going to be equal to the float, typecasted float of the total supply. And we're going to use that total supply in order to make some calculations down the line. So first we need to calculate the price that it's going to be, the price of each currency at the $7 trillion point, because that's the value of all of the coins and banknotes in circulation. So the way we're going to do that is we're going to say $1,000,000,007 price is equal to 7.7 trillion. Now, numbers at the trillionth place have 9 zeros, so we need to add 8 more to this one. So 1, 2, 3. 1, 2, 3. Or excuse me, they have 10, 11, 12 zeros. They have 12 zeros, so 3 more zeros. Times the percentage of global cap divided by the available supply. And we want to round this number to 2, so we'll put this entire thing in a round function. And now we want to do the same thing for the rest of these values. So we also want to get 36.8 trillion, 73 trillion, 90.4 trillion, 217 trillion, and 544 trillion. So let's copy and paste this and edit the values. So we need 1, 2, 3, 4, 5 more. This next one is trillion 36. then we have $1,073,000,000, then $1,090,000,000, $1,217,000,000, and $1,544,000,000. And so we need to convert these. $1,036,000,000, that'll be 36 plus another 0. $1,073,000,000 will be 730. $1,090,000,000 will be 904. $1,217,000,000 will be 217,000,000. $1,544,000,000 will be 544,000,000. Now let's convert all of these into strings. So we'll say percentage of global cap string is equal to string, typecast as string, and then we're going to round the percentage of global cap times 100 to 2 decimal places, and we're also going to add a percentage sign afterwards. And then current price string is equal to $ plus the string, typecasted string of current price. And then we have to get string values for all of our trillion prices. So we got $1,000,007,000,000 price string is equal to $, and this is where locale comes in. Locale.format, and we'll say %.2f to get it down to 2 decimal places, comma $1,000,007,000,000 price, comma true. And we'll just copy and paste this for all of our values. We have 6 of them, so 5 more. So $, so we've got 36, we've got 73, we've got 90, 217, and 544. And let's go edit all of these as well. 36, 73, 90, 217, and 544. Something I noticed is up here you need to change en-us to en_us in order for it to run correctly. And down here just add print table, and another print to make some space. And let's go ahead and add all of these values to our rows. So we'll say table.addRow, and then it'll be name, ticker, percentage of total or percentage of global cap string, and then we have current price string, $1,007,000,000 price string, $1,036,000,000 price string, $1,073,000,000 price string, $1,090,000,000 price string, $1,217,000,000 price string, and $1,544,000 price string. And let's save that, and let's try and run it. me change into the correct directory here. And there we go. We have the top 100 ranked cryptocurrencies and their future values. So I thought this project was a lot of fun. If you guys find any other real-world applications and would like to create projects in them and want my help, you can send me a message and I'll add another project to this Udemy course. And also, I thought this article is pretty cool. I'll link it if you guys want to check it out. It just shows you the future growth potential of all the cryptocurrencies. So we have one more video or one more project left, and we're going to be adding 1,000 cryptocurrencies to an Excel file. So I'll see you guys in the next one. In this final project, we'll be appending 1,000 cryptocurrencies along with data about each to an Excel workbook. And Excel has a lot of useful functions like making charts and things like that, and it can come in handy when we want to graph out all of this data or whatever data you want to. We're going to use a library called XLSX Writer. So you're going to need to install that with pip. So we can say pip3 in our terminal, install XLSX Writer. If that doesn't work, try sudo pip3 install XLSX Writer. And if you're on Windows, just pip install XLSX Writer. And so let's go ahead and get started. Let's get started by creating a new file. We'll say file save as CoinCap p5.py. And for this, we're going to need a few libraries. These include XLSX Writer, which we pip installed in the last lecture. We're going to need requests, and we're going to need JSON. So to get started, we're going to have two variables. One is the start. We're going to be using this number to paginate through files. So with the current ticker URL endpoint, we can only get access to 100 cryptocurrencies. But if we want to get the next 100 cryptocurrencies, we have to start at 101. And then if we want to get the next again, we have to start at 201. So we're going to loop through that 10 times and get up to 1,000 cryptocurrencies. And then we need another variable called f, and we're going to call this 1. We're going to be using this to append values to our Excel workbook. And our first 0 would be the header column, or the header row. So we just want to skip that and go straight to 1. So we're going to say crypto workbook is equal to XLSX writer dot workbook with a capital W, cryptocurrencies .xlsx. And now we need to add a worksheet to this workbook. So we're going to say crypto sheet equals crypto workbook dot add worksheet. And we'll call this, or actually this just has parentheses. And then we need to make some header columns. So we'll say crypto sheet dot add or dot write A1. A1 is specifying the topmost left cell name. So name will be in the top leftmost cell. And then we're going to move one over to the B column. So we'll say crypto sheet dot write B1 symbol. And And let's just copy and paste this and add the rest of ours. We're going to go all the way up to H. So we've got C, D, E, F, G, and H. Then we've got market cap, price, 24-hour volume, hour change, day change, and week change. So now we're going to get our 1,000 results by calling the API 10 times. So let's go ahead and get started. So for I in range 10, we're performing this action 10 times. We'll say ticker URL is equal to https api.coinmarketcap.com v2 ticker, and the structure is equal to array, and start is equal to the string form of start, which will be 1 in the beginning, and then we'll keep on adding 100 to it in order to get the next 100 results. So now let's make our request. So request equals request.get ticker URL. Results is equal to request.json. Data is equal to results data. And then we're going to loop through our data. So for currency in data, we're going to get the rank. So that's equal to currency rank. We will get the name, currency name. We will get the symbol. That's equal to currency symbol. And quotes is equal to currency quotes. USD, got to get down to that quotes level. And then we say market cap is equal to quotes market cap. And got to get hour change, day change, week change, price and volume. So hour change is equal to quotes percent change 1H. Day change is equal to quotes percent change 24H. Week change is equal to quotes percent change 7D. Price is equal to quotes price. And volume is equal to volume 24H. Volume string is equal to, actually we'll leave out the volume string for now. Now we just need to start writing all of these values to our crypto sheet that's in the crypto workbook. And then once we're finished, we'll just close up the crypto workbook. So we'll say crypto sheet dot write F, and F is going to be the value that goes that specifies the row. So up here it's set to 1, and every time we loop through, we'll increment it so that it goes down 1 row every time we make an addition. So F0 is at column 1, and at column 1 we'll append the name. So we're going to have 7 of these, so I'm just going to copy and paste. So then we have 1, 2, 3, 4, 5, and 6 for the column indexes. And then up here we'll have symbol. We will have market cap, well, the string form of market cap. Make sure to typecast that. And we'll have the price. We will have the volume. And hour change, day change, and week change. So we gotta add one more. Hour change, day change, and week change. And now right here we'll say f plus equals 1 to increment the row we're on, and then one level down we'll say start plus equals 100 to paginate through our API, and then finally we'll close our workbook to save it. So I had a couple of errors there. Make sure you set request equal to requests with an s.get ticker URL, set volume equal to quotes volume underscore 24 hour, and then make sure instead of 6 duplicated here you have 7. And now I'm just going to save this and let's run it. And once this is complete, we'll have an Excel file that we can open up. And this has all of the data, which we can format using tables, graphs, or anything else that Excel allows us to do with it. Or you can upload it to Google Sheets. So that's the end of project 5. And in the next project, or in the next video, I'll show you how to use GitHub to upload all of your projects and make a new repository and keep your code updated. So thanks for watching, and I'll see you guys in the next one. So GitHub is a website where you can store your code for free, and if you don't have an account already, go ahead and make one if you would like, and we'll create a new repository and store all of our code here. So once you've created an account, go ahead and click this plus and say new repository, and we're just going to call this CoinMarketCap repo. You can make it public and just click uncheck create with a readme and click create repository. Now let's go into terminal and let's navigate to our CoinMarketCap folder, which is on the desktop. So we'll say cd desktop / CoinMarketCap. And let's actually organize these files a little bit. I'm going to close out this Excel file, and we'll make some new folders in here. I'll call this one API. We'll have P1, P2, P3, P4, P5. Then let's put everything that belongs in API in there. This goes in P2, P1, P2, P3. This goes in API, P5. You can delete this and throw this in P1. And then I'll create another new folder called projects, and I'll throw all of these into our projects folder. So now let's say ls to list what's in this directory, and we have 2 subdirectories. So now we're going to initialize our Git repository with git init. This just says we want to create basically a repo and keep track of it in this folder right here. And then we'll say git add dot, which means add everything in these 2 subdirectories to our repo, our local repo. And then we're going to say git commit -m, which means a message, and we're going to say initial commit. So as you can see, we have 12 files changed and 554 insertions. And now we're going to come back over to GitHub, and we're going to copy this to add our remote origin to our GitHub repo. Press enter. And then the last thing we're going to do is push it to the master repo, which is located on github.com. And now it's complete. Just refresh the page, and all of your projects and files will be located here. And if you want to follow me on GitHub, my username is Ianace, and I'll give you a follow back. Well, thank you guys so much for downloading my Udemy course, and I wish you guys the best of luck in your future programming endeavors. If you guys want to send me any ideas for new projects, I'll be happy to add them to the course. Or if you guys make some new projects with the CoinMarketCap API, just send them my way. I'd love to see them. And I'd also love to see anything else you guys are working on. So I hope you guys have a great day, and thank you so much for downloading the course. I'll see you guys in the next one.